Let's talk about the invisible ingredients that power, well, pretty much everything. We call them critical minerals, and you'd be shocked to find out just how much of our modern world relies on them. Seriously, without these things, our daily lives would look completely different.
Just think about the smartphone that's probably in your hand or pocket right now. Ever wonder what makes that screen so vibrant, or how that tiny motor buzzes so perfectly? Yep, that's all thanks to a special group of minerals called rare earth elements. They are the absolute secret sauce of today's tech.
And we're not just talking about small gadgets here. The huge shift to electric vehicles, you guessed it, that's powered by rare earths too. Those super efficient, high-performance motors in EVs, they need incredibly powerful yet lightweight magnets made from elements like neodymium. The scale gets even more mind-boggling when you look at the green energy revolution. A single large wind turbine, just one, can have over 350 kilograms of rare earth elements inside its generator. So yeah, it's pretty clear our future is deeply connected to our access to these materials.
So what exactly are these things? Well, rare earth elements, or REs, are a group of 17 metals. And here's the funny thing, they're not actually all that rare. Their real power comes from their unique magnetic, electric, and optical abilities, which make them absolutely essential for over 200 different high-tech applications, from our phones to critical defense systems.
And that brings us to the heart of the matter. Where do we get these essential elements? Because the answer reveals a massive, and I mean massive, global choke point.
See, it's not just about who digs the ore out of the ground. The most important, most difficult stage is the processing, turning that raw rock into the super pure materials manufacturers need. And in that critical middle step, China controls a staggering 90% of the entire global market. That's not just influence, that's dominance. So how did this happen? Well, it wasn't by accident. China played the long game, strategically investing nearly $57 billion in mining and refining projects all around the globe. This secured their influence, not just at home, but across the entire supply chain. And look, this is not some theoretical risk. We've seen this power used before. Back in 2010, after a territorial dispute, China completely cut off rare earth exports to Japan. It sent absolute shockwaves through global tech industries and was a crystal clear signal that this economic power could be used as a political weapon.
Okay, so what's the alternative? To understand the challenge, we're going to zoom in on one place that tells the whole story: America's one and only operational rare earth mine.
The Mountain Pass mine in California has had a total roller coaster of a history. Believe it or not, back in the 60s, it was the world's #1 supplier. But by 2002, crushed by environmental hurdles and fierce competition from China, it shut down. It tried to come back, went bankrupt in 2015, and was finally bought in 2017 with a new mission: to rebuild an American rare earth industry from the ground up.
And here's a glimpse of why this is all so difficult. Getting from a chunk of rock to a pure element is a brutal chemical marathon. First, you grind the ore, then you separate it using froth flotation, then you dissolve it with acid, and then you begin this incredibly painstaking process of solvent extraction to separate each individual element. It is incredibly hard, expensive, and a huge environmental challenge to get right.
But today, Mountain Pass is back in the game, and it's a vital piece of the puzzle. As the only integrated facility in the U.S., it was already supplying nearly 16% of the world's raw production back in 2020. That's a huge step for sure, but it's still just a piece of a much larger global picture.
So if one mine isn't the whole answer, where is all our future supply going to come from? Well, beyond just restarting old mines, there are really two big paths we can take. And you have to understand, this is a moving target. Just look at how the risk changes over time. On the left, in the short term, you see stuff like dysprosium deep in the critical red zone. Now look to the right, into the near future. All of a sudden, materials like lithium and nickel, which are absolutely essential for batteries, jump right into that high-risk, high-importance category. The problem is constantly evolving.
So how do we get these materials? Path 1, new mining. The upside, a potentially huge, stable supply. The downside, it can take 10 to 15 years, years, to bring a new mine online, and it's incredibly expensive. Path 2 is what we call urban mining, a fancy term for recycling. It's cleaner, it's smarter, but the technology is really complex, and let's be honest, we are terrible at collecting our old gadgets.
And when I say terrible, I mean it. Check out this number. Right now, less than 1% of all rare earth elements are ever recycled from old products. Less than 1%. That is, well,
It's a huge failure, but you know what? It's also a huge opportunity.
And there is some really good news here. Some of the best future sources for recycling are the very technologies we started with. Those big, powerful magnets and retired EV motors and old wind turbines are a gold mine, or a rare earth mine. They can be recovered much more easily, potentially creating a closed-loop system for the whole green economy.
So as we start to bring this all together, what does it all mean for the future of our tech, our economy, our security? I think it's fair to say the stakes could not be any higher. So here are the key things to remember. 1. Demand for these minerals is about to go through the roof. 2. The global supply chain has a serious choke point, and that's a major geopolitical risk. 3. Building new mines is a solution, but it's a very slow and very expensive one. And finally, recycling has incredible potential, but it needs a huge leap in technology and logistics to actually work at scale.
So much of our world, from the device you're watching this on to the clean energy systems we're counting on for tomorrow, is all built on a foundation of these rare earth elements. So the big question we really have to ask ourselves is, have we built our world on solid ground,